maybe the better comparison is to look at Tesla. Where did Tesla start? Did Tesla start transform the automotive industry to go towards electric cars by building a very, very cheap electric car that everybody could afford? No, they did not. They started with the higher end price segment, where actually you only need to produce a few and you can, collect a decent price for those. And then with the money that they generated with that, they were able to build a bigger factory that can produce in higher volumes and bring the price point down to where more people can afford those cars. It's a similar story with aviation. If you wanted to build a 100 or 150 seater aircraft today, not only is the battery technology not ready yet for the distances that airlines want to fly, that's also about a 10 billion pound or euro project to be able to bring an aircraft of that size into the market. That's not something that a startup can afford to do. And in fact, even the big incumbents like Airbus and Boeing, every time they develop a new aircraft like that, they are betting the farm, the future of the whole company, on that one new aircraft project.
Hello, my name is Zan Phillips, and welcome to Your Green Voice, the show where we celebrate people who are making this planet greener, cleaner, and better. Our next guest can possibly solve the frustration and aggravation that environmentalists have about private jets. His name is Josef Mouris. He's a former pilot with Flybe, flew out of Southampton for 15 years, and has seen a gap in the market for small electric aircraft. The aircraft is the Electron 5, and it can potentially service a wide variety of areas within the aviation industry, but also in the future introduce on-demand flying to the wider public. The beauty of this aircraft is that it is quiet, almost pollution-free, and the company itself is just £5 million away from its first flight. So welcome to Your Green Voice, Josef Mouris, CEO and co-founder of Electron.
Zan, fantastic to see you again. Thank you for having me on.
It's a pleasure. Now, before we get talking about this beautiful aircraft, can you tell the viewer about decarbonization in the aviation industry and where we stand at the moment?
Yes, decarbonization of aviation is a hot topic, and is going to become increasingly more of a hot topic in the years to come. As all industries are cutting their emissions from where we are today to where we need to be by 2050, and aviation is set to go from around 3% to 20% of all global emissions in that period of time, unless we make a change. And so what we're going to see is more incremental improvements in fuel efficiency in existing aircraft from the incumbent manufacturers. But then what we're going to see is a change to electrification for short haul, and a mix of sustainable aviation fuels and offsetting emissions for long haul flying.
That's a very interesting way of looking at it, because I'm sure a lot of people would want electric to be the way forward for everything. But you seem to be suggesting that long haul isn't going to see electric aircraft. Why is that?
Yeah, so there isn't a single silver bullet solution for aviation like there is for automotive. Of course, electric cars is the future for automotive. That's quite clear by now. But batteries are not good enough to fly halfway around the world. And when you look at hydrogen, which we'll come back to in a minute, there are some issues there as well. So that's why actually we think it'll be split between short haul, which will be electrification, and long haul will use sustainable aviation fuels.
So you mentioned hydrogen.
Yes.
People are trying to put it into cars, farm vehicles. Why can't they put it into aeroplanes? What's wrong with that?
Yeah, so there is a massive hydrogen industry today. We need a lot of hydrogen in the world for things like fertilizer, for the steel industry. Some of the hydrogen gets used again straight away in the fossil fuel industry to actually crack oil into its various components. But 98% of that hydrogen is produced from fossil fuels today. So the hydrogen industry as a whole produces nearly as much emissions as the global aviation industry does. So it's not necessarily a practical solution from an emissions standpoint to start using hydrogen unless we actually produce more green hydrogen. And green hydrogen is very expensive, a lot more expensive than just charging up your electric car or your electric plane with electricity from the grid. So the three production hydrogen cars that exist in the world all actually cost a lot more to buy and to use than electric cars do. And they don't necessarily have that much more range. In fact, they actually have less range than a Tesla Model 3 long range.
So electric seems to be the answer. Obviously, you're wedded to this, and what you've designed here is a beautiful plane. It's traditional, and most people would recognise it as an aircraft to go in. There are modern electric aircrafts that some people might be aware of, and I think these are electric vertical takeoff and landing planes. What's the difference between those and yours?
Yes, so the eVTOLs, as their acronym is used quite a lot, have been in the spotlight a lot. There's been a lot of hype around them, and it's like the Jetsons, It's this dream of being able to go from your home to your work, take off vertically and land vertically, and not be stuck in traffic somewhere. It's very exciting. Unfortunately, the practicalities of it are that this is an entirely new class of aircraft. It's not a helicopter. It's not a plane. And the certification pathway for those doesn't exist yet. So that's the thing that those companies have been working on for some time now at great expense. But ultimately, there are regulations around to keep us safe. Aviation is one of the safest industries or mode of travel if you look at it per passenger kilometer, per passenger mile compared to even driving. And we need to keep it that way. So those aircraft will need to meet those certification standards like any other aircraft. And that's a bit of a problem.
But one benefit then for your aircraft is the fact that it's using runways. And am I right in saying that the regional airfields that we've got are underutilized at the moment? And this could be a fantastic way of reinvigorating that particular part of aviation.
Yeah, that's right. So today, about 80% of the passengers fly through just 1% of the airports globally. We have a wonderful airport here, Southampton, where I used to fly from for 15 years. For Flybe, when I was there, we did around 97% of the movements from the airport. And in 2020, during COVID, when all the airlines were putting their pilots on furlough, that was also the moment for Flybe for things to end, unfortunately, which was sad. And so Southampton became Sleepy Hollow all of a sudden for at least for a while, which is a shame. And we've seen this trend of these regional connections disappearing over the last few decades in the US, here in Europe. And that's really a shame. And it's driven by airlines being able to only really make things work with a large aircraft with 100, 180 seats flying between the big city pairs. They can't seem to make it work economically for the smaller cities, the smaller airports. And so this is where electric aircraft changed the game entirely, because you are actually able to bring the operating costs of those small aircraft down to a point where everyone can afford it. To be able to fly what now we think of as private aviation, but I'd like to call it actually regional air mobility.
In some respects, we're leaping ahead to the future here for the sort of on-demand flying. But just to stick on that point, because these are very quiet planes, and I work in Southampton, and the planes come overhead, and occasionally you do see a private jet roar in. How quiet are these? Would I actually notice one of your electric planes flying over my head?
No, you probably wouldn't hear it. Electric planes are so quiet that when they fly, because they also need to fly, planes need to fly a certain height over a city. You're not allowed to bust somebody's house for good reason. Because they're so quiet and they fly at that altitude, they basically produce the same amount of noise as a conversation. So with all the noise that a city produces, you just don't hear them. And we already know this is true because there are some two-seater electric planes flying around already today. And there have been noise measurements with those planes to confirm how quiet electric planes are.
Well, that's fantastic, because that's one of the things that people get irritated about with private jets. They're noisy, they fly in, but also it's the pollution. And this is one thing we haven't really discussed with the Electron 5 is how much pollution does it generate and how does it compare to other modes of transport?
Yeah, so I think it's a good idea to kind of frame where private aviation is today. As you say, it's very expensive, making it only really accessible to the elite. It produces a lot of emissions, not necessarily in total, but per passenger mile or per passenger kilometer. It's really, really bad. And so it's not really a solution that we kind of want to scale up for the general public in its current form. The irony is that with electrification, actually, we take what is now something that's really expensive and make it as affordable as commercial aviation, and definitely in this country, the train, but actually able to connect the regions much faster than we can today by car and by train, and have these connections that also don't exist by air today. But then we do it with less emissions than driving an electric car.
Really?
Yes. Yeah.
An electric car?
Yes.
Amazing.
The reason for that is electric cars, or cars in general, spend most of their life parked up. The average car does maybe 200,000 miles in its 15-year life. And these planes will do more than 10 million miles in that same time span. So if you look at the embodied emissions in the vehicle, you are able to write that off over a lot more miles or kilometers with an electric plane than you can with a car. And that's combined with that we don't need the infrastructure. We need a runway at either end, but we don't need the 800 or 500 miles in between. Actually means that on a per passenger basis, electric flying is greener than an electric car.
Amazing. That sounds very exciting.
It is, yeah.
But the way to market, as lovely as it would be for everyone to suddenly be flying by electric plane, your approach is different. You're talking about a sort of top-down approach. Can you explain to the viewer what that is?
Yes. So when most people think about flying, they think about a big commercial airliner with 150 other people. They don't necessarily think about private aviation or a private jet. Most people have never been on a private jet. Most people also haven't been on a helicopter either, which, again, the eVTOLs is more like a more expensive replacement of existing helicopters than anything else. And so if you look at it from that perspective, maybe the better comparison is to look at Tesla. Where did Tesla start? Did Tesla start transform the automotive industry to go towards electric cars by building a very, very cheap electric car that everybody could afford? No, they did not. They started with the higher end price segment, where actually you only need to produce a few and you can collect a decent price for those. And then with the money that they generated with that, they were able to build a bigger factory that can produce in higher volumes and bring the price point down to where more people can afford those cars. It's a similar story with aviation. If you wanted to build 100 or 150 seater aircraft today, not only is the battery technology not ready yet for the distances that airlines want to fly, that's also about a 10 billion pound or euro project to be able to bring an aircraft of that size into the market. That's not something that a startup can afford to do. And in fact, even the big incumbents like Airbus and Boeing, every time they develop a new aircraft like that, they are betting the farm, the future of the whole company on that one new aircraft project. So that's why basically we're starting with top down, higher price segment, and then eventually we will build bigger planes for the busy routes between the big cities, the type of flying that most people are familiar with today.
And you say that the Electron 5 can provide a wide variety of services within the aviation industry. Can you give us an example of some of those?
Yes, so of course, private aviation is one of the market segments that is most interesting for us and making it more mass market. But next to that, it's also the ideal size for pilot training. So the second stage of your pilot training, you need to do that in a twin engine aircraft. And as you can see, it's a twin engine aircraft and it's perfectly suited for that second stage of pilot training. Then we have logistics customers. So there's a massive logistics use case right now. Today, a lot of the things that get transported by air kind of go through this hub and spoke system to get from A to B. And with small electric aircraft, we can actually do more point to point. And that really reduces the emissions and also the time that it takes for these parcels to get from A to B significantly. Then there is defense use cases. 5 years ago, defense was a dirty word, especially when you're talking to sustainability investors. But we don't live in 2020 anymore today with everything that's going on in the world and in Ukraine and beyond. And so Europe needs to, stand on its own 2 feet, and it is making moves in that direction. And we are seeing significant interest from defense customers as well.
So if we go back to business flyers, because you say that's probably the market you're targeting the most, have you got 3 or 4 benefits for business flyers that this electric aircraft can bring them?
Yes. So today, the business aviation or the private aviation market, so business travelers will fly with airlines where they have kind of limited flexibility in terms of when they can fly and where they can fly to, or they will fly with private aviation, where, as mentioned, the price is very high, the emissions is very high, which is something that also they kind of need to justify and get more and more questioned on. And actually, the booking experience is kind of really old school today. It's not like booking an Uber. So with electric aviation and actually having a lot of these electric planes flying around everywhere, you can think of it more as an extension of Uber Green, where it's very convenient to book it on your phone when you need to travel. It's going to be up to 90% cheaper than private aviation is today. It's going to be zero direct emissions, but cleaner than even an electric car. And it's going to be widely and easily accessible. So that's kind of the main points where business aviation and business people are looking forward to being able to jump on an electric plane.
Well, it's very exciting hearing you talk about the Electron 5, but whereabouts in the project are you and the team?
A very good question. Yeah, so 4 or 5 years ago, we started wanting to be an operator. And we wanted to buy electric planes to be able to start offering these kind of services. And we scanned the market and we couldn't find what we were looking for. The battery technology is there. The regulations are there. But today there's only two-seaters in the market, which doesn't really work to be able to fly customers with luggage from A to B, considering you also need a pilot. So we ended up deciding that we were going to build our own plane instead. And a lot of work's been done by us, our engineering team, since then. We actually also moved part of the company from the UK to the Netherlands so that we fall under EASA, which is the regulatory body for certifying aircraft in Europe and a few other countries. Not just the CA, not just the CA here in the UK. And we passed what's called the design concept review. So that means that our engineering team has dug into all the kind of variables, the legislation, the manufacturing processes, the batteries, everything, and put together basically a summary of what the aircraft is going to be like, how it's going to be produced, what it's going to be made out of. And that was audited by a third party to make sure that we haven't missed anything, that we're following the right process, and that, yes, actually, we can build an aircraft with today's batteries that can fly the range that we say it can. So that's given us and also our customers and investors a lot of confidence to say, yes, now is the right time to turn that aspiration into something that we can, touch and feel and build a flying prototype of the aircraft. And that's what we're going to be doing next.
And you're £5 million away from that, which in aviation terms, it seems like a drop in the ocean.
Yes, if you look at the amount of money that has flown into the eVTOLs, the vertical takeoff and landing aircraft, 5 million doesn't seem like a lot, but it's actually all we need to build a non-certified prototype, so an early prototype demonstrator, to actually get to a certified aircraft that we can sell to customers, that customers can use to fly fare-paying passengers with. We need a lot more money than that, but 5 million is all we need after all the work that's already been done to build our first flying aircraft.
And if everything went according to plan, obviously things change. You've got to be certified. There might be a little minor problem with twerk or quirk. When do you see this actually being in operation?
So we're aiming for first flight of the first prototype in 18 to 24 months' time from now. Then following that, we will need to build a production facility because the production tooling is part of the certification process. So we don't expect to actually have a certified aircraft until early 2030s, so 2031.
Yeah. 2031. Okay. Well, that's not too far away, but
it isn't. If in the grand scheme of thing, if you look at where we are now to 2050, when we're supposed to be completely decarbonized or zero emissions in aviation, and this isn't a race; it's a marathon.
Right, but but at the moment you're at the forefront of this.
Yes.
What kind of interest are you seeing from various aspects of the aviation industry?
Yeah, it's an interesting question, especially statement when you say we're at the forefront of this. If you look in the market and see all the other projects that are out there, we've covered hydrogen, we've covered eVTOLs, then there's actually not that many companies that are building pure clean sheet battery electric aircraft like we are, and then they're also building them in different sizes. So if you actually look at the kind of size aircraft that we're building, we only really have one strong competitor, if you will, and they're based in the US. So in Europe, we're kind of like at the top of the leaderboard, if you will, of getting this done. And that also means that all the customers that are looking for an aircraft of this size are talking to us because we are the only ones that are doing it, and are already that many years into the process.
And is it kind of, you mentioned defense earlier, you mentioned logistics. So is it, can I say people like Amazon, are they knocking on your door? Or airline companies who want to train their pilots? Is those kind of things?
Yes, we've had conversations with pilot training organizations. They're not necessarily the kind of companies that have a lot of spare cash. And we're obviously looking for customers that are also going to put down, put the money where their mouth is and put deposits down for aircraft. So we actually found our first customer on the other side of the world in Australia. We've got customers in Germany. We've got customers in the US. We have a logistics customer. So these are all companies that are flying passengers, private aviation, business aviation passengers. Then we have a logistics customer in Europe that's actually decided to invest in us as well. And now at the moment, we're exploring a few early days, but conversations with defense customers.
And I've got a quote here. You saying Electron is the future for aviation, aerospace, and automotive. What do you mean by that?
Yeah, it sounds like a lot, right?
Mm-hmm.
And so you'll have seen the transformation in automotive industry from combustion engine cars to electric cars. Unfortunately, here in Europe, we were a little bit slow. And so the automotive industry is struggling, shall we say, at the moment, really struggling with competition from China. And so if you consider that in aviation, we're going to move away from where we are now to short haul being all electric and long haul being on SAF, that means we need a lot of electric aircraft for short haul. But in aviation, unlike automotive, when you certify a plane here in Europe, you are protected from competition from China. You cannot certify a plane in China and sell it here in the European market or in the US market. So that means that actually for automotive industry, where there's a lot of experience in manufacturing, particularly automated manufacturing, the level of automation in aerospace manufacturing today is really, really low. We can use those brownfield sites, if you will, that are now building or have been building cars to actually building airplanes in Europe. So that's why it's not just the future of aerospace we're talking about. This could actually be the rescue for the automotive industry in Europe.
Going back to the plane and the fact that it's a 5-seater, but pilot plus 4 and baggage.
Yeah, size of a car.
Size of a car, yes,
Yeah.
taxi. And why not an 8 or a 9-seater or something a little bit bigger so you get more fee-paying passengers in?
Yeah, it's a good question, and we get asked that a lot. Coming back to it, airlines want to see at least 80 seats. That's what for them makes sense to operate economically. They want at least 1,500 kilometers or 1,000-mile range. We can't do that with pure electric aircraft today, and an aircraft of that size would be also very expensive to develop, like 10 plus billion. So that's from an airline perspective. For private aviation and the way that we actually travel by car today, keep in mind that the kind of trips that we're looking to cover with these aircraft is, say, 500 to 800 miles or kilometers. Most of those are done by car today. And so you need a car-sized vehicle to replace those trips. It's on demand. It's not scheduled. So the second you start to move away from an aircraft of that size, because in private aviation and automotive, in the car on the road today, you typically have 2 people. The second you start to move away to 9 seats or 20 seats, you effectively need to do scheduled operations. You become like an airline. But then you're not able to offer the same competitive low prices as airlines do, right? So there's basically a big dead zone between sort of 5-6 seats and 80 seats. And in that space, yes, there are a lot of 9-seater-ish private aviation jets, but these are the top segment. Like, these are really high net worth individuals. It's more of a status symbol than it is a practical way of saving time and flying from A to B. That's not the market that we are focusing on.
Yeah, I mean, I see your point. It's very rare that you actually order a 6 or 7-seater taxi, isn't it? It's generally just you, a couple of people, and then off you go.
We have about 1.6 billion cars in the world. Would you like to guess how many planes there are in the world?
I haven't a clue. Okay, I'm going to guess 500,000.
Maybe if you add every single plane in there, but there's only around 30,000 or so actively flying commercial airliners in the world today.
Wow.
Yeah, and then another 30,000 or so private aviation aircraft. Yeah, and then there is maybe another 250,000 general aviations, so private, really small aircraft that don't get used a lot. They're parked up most of the time. Yeah.
Amazing. Well, I've got a couple of questions that are not necessarily about the company, but about the effect this might have. And also, first of all, historically, because Southampton and the South Coast has a great aviation history.
Yes.
And here you are following in the footsteps, or in the flight path, let's say, of people like R.J. Mitchell, who came to Southampton. He developed 24 planes, the last one being the Spitfire. Do you feel like you're in that position, or am I over-egging this?
I'm not going to compare myself to the greats of history, and also Whittle, like the jet engine. Absolutely not. But there is a very rich aviation heritage in the UK here. I'm originally from the Netherlands. I moved here about 20 years ago. I've been an airline pilot here for 20 years. I've lived here longer than I have in the Netherlands. And operating from Southampton Airport, where the first Spitfire flew, Yeah, it's interesting. Yeah, it feels like there is actually a lot of legacy to live up to, but we do know that this kind of change doesn't tend to come from the incumbents. We've seen it in automotive. It took a crazy person at the helm of Tesla to bring electric cars into mainstream, and so we need a startup like Electron to drive this change in aviation and the aerospace industry as well.
And the point, someone watching this conversation, listening to it, and thinking about all these planes flying around, have you thought about, will it overcrowd the skies? What are people going to be feeling like? Because there is quite a few science fiction films that you watch where you see these lines of flying vehicles going, and you think, it looks a bit oppressive there. Have you contemplated that, or thought about how many planes you can take in the sky? I mean, air traffic control, for example, can they handle the amount of flights that you're talking about?
Yeah, so for me, it's quite critical, having been an airline pilot, to look at this very pragmatically. Like, how is this whole industry going to transition, and what is the future going to look like? And I have firsthand experience of how busy the airspace actually is and how busy the airports actually are. And that's where I come back to say, 80% of passengers fly through just 1% of the airports. What about the other 99% of the airports? They are actually massively underused today. And it's actually quite often costing a lot of money to keep those airports open. Some of them turn into housing estates or business estates. But what if we can actually use those airports to reconnect the regions much more effectively in a very, very sustainable way and drive clean growth? Those airports can become energy hubs, if you will, and mobility hubs versus what they are today. The airspace up there, if you step outside today and you look at the road, you'll see quite a lot of cars parked up. When you look up into the sky, I bet you can't even see one airplane. The skies are empty. The skies are not full. That's not the problem. Yes, there is congestion at big airports like Heathrow and Gatwick, but these are not the airports that I'm talking about.
It's the sound of the plane that fills it up. If you think about it, because one plane can actually fill the whole sky with sound.
Yeah.
And therefore, if you put in more planes in the sky, but they make no sound, then potentially you wouldn't even look up.
This is the thing. So electric planes are not just very much cheaper to operate. They are also incredibly sustainable, green. So it's actually a very positive future to look out for in the aviation and aerospace industry, which is something that we need. But there is more than just emissions. There is also noise pollution. And it's right. It needs to be quiet. There needs to be a focus on making sure that these aircraft are very quiet. Southampton University actually has a really interesting history in acoustics, aeroacoustics in aircraft. And we need to make use of that. We need to make sure that these aircraft are as quiet as possible so that they do not become a nuisance to the general public.
And one question we haven't actually asked, but actually in the plane, there's two sides to an electric car that everyone loves. One, it's quiet, and the acceleration.
Yes.
Because you go, wow. And I was in one the other day, and actually I did go back. We were traveling at 40. He put his foot down. We went back in our seats. It was quite amazing. Yeah. Is that the same feeling when you fly? I know you've only been, there's a couple of two-seaters around, but is that the same kind of feeling you get in those planes?
So the irony is that we've actually sent our whole engineering team up into an electric plane before in a two-seater to experience what it's like. I myself have done a lot of glider flying. I've done a lot of commercial airline flying, but I've actually not flown an electric airplane yet. I'm saving myself for our own aircraft.
Right.
Yeah, I will not be doing the first flight on it. That's the job of a test pilot. It's qualifications I don't have, but I will be taking my first electric flight in our own aircraft. So yeah.
But with the engineering team, did they report back, say, yes, it's quieter, yes, you can actually accelerate?
Yes, so the experience that everyone is saying, it's incredibly quiet. The acceleration is instant, like in an electric car. Keeping in mind that an electric motor is about 10 times the size than a combustion engine, or effectively it's 10 times more powerful per pound or per kilo than a combustion engine. So it's really easy to pack a little bit of extra punch into the vehicle without it costing a lot of weight. Yeah, so it won't be boring, but of course we also don't want necessarily planes to climb up vertically. I don't think passengers are going to appreciate that either.
Joseph, I've got a sort of side question for you, but I noticed you brought a box into the studio, and I'm intrigued. What is in the box?
Yes, yeah. So when we met the other day, I had a little model of the E5 with me.
Very good. Yes, I remember
what
it very
the
well.
aircraft, the prototype that we're going to build actually looks like. It's moved on a little bit than what you see on the screen and what you see on our website. The plane looks a little bit different now. In one way, a little bit more conventional. It doesn't have the canards, the little wings on the front of the fuselage anymore, which is also a bit more convenient in terms of people not walking into it. But yes, the new design will be released at Aero Friedrichshafen next month. And we've been sending out a few of these little planes to a few people. So I've got a couple with me here. And this particular one, is in orange and light blue. And there's like a little logo on the back that you might recognize from KLM.
Yes, KLM.
Yeah, this one's actually for the King of the Netherlands. As you know, I'm Dutch, and to be fair, I'd like to send one to King Charles as well. But he actually is an airline pilot as well, or has a pilot's license, and he flies the state plane, and he flies for KLM to keep his license valid.
Wow.
Yeah. And so he took his first flight also at Teugen Airport, which is where we had our hangar, where we've built the mock-up of the cabin. He had his first flight there, and he's really into aviation. So I met him already a couple of years back now at the opening of a charging center, where they do all the testing and compliance testing for chargers. And of course, we're going to need chargers for electric aircraft as well. And through a few contacts, we were offered actually to fly the King. So I think he's keen to fly as soon as he can in this plane, an electric plane. So I'm going to be sending this one to him through his brother, who's very active in deep tech and technology and the ecosystem in the Netherlands. So yeah, I thought this one might be the nice plane to kind of show.
That's fantastic.
But we're sending these ones, and we've sent in total 40 of them out to various people. I think the one that you saw when we met last, the red one, was for Lewis Hamilton, for instance.
Fantastic.
Yeah.
Has he returned the favour and sent you little models?
So Lewis, get in touch. No, Lewis hasn't, but we have had some really interesting replies so far from people.
Yeah, because I think he's a helicopter pilot himself, isn't he?
So Lewis is active in all sorts of areas, and obviously he's a legend here in the UK and as a Formula One driver. So yeah, it would be great if maybe Lewis wants to add an Electron 5 to his lineup, to his fleet of aircraft as well. Yeah, why not?
Well, Josef Mouris from Electron, it's been a pleasure talking to you about your beautiful aircraft. Very exciting conversation, and we wish you the best of luck for the future.
Thank you very much, Sam.